As I'm sure you're aware, the purpose of this program is to discuss repair procedures for centrifugal pumps. But I think before we get into discussing the maintenance of these pumps as such, it might be a good idea to take a closer look at a typical centrifugal pump and see what it takes to make up this piece of equipment. Now, I recognize that this may be a review for a number of you, but I think it's a beneficial review at this point. Now, what we see here is a typical horizontal, two-stage, split-case centrifugal pump. Let's see if we can identify the major components of this pump. The casing is the housing of the pump. It surrounds the pump impellers, the shaft, and the packing glands. In addition to providing a pressure enclosure, the casing also directs the flow of liquid into and out of the pump impellers. As I said, the casing of this particular pump is horizontally split. That is, the top half can be lifted off for maintenance of the pump internals. The casing of this particular pump also forms the supports for the bearings, which in turn support the rotating element. This pump makes use of two sleeve bearings and a multi-disc thrust bearing. In other centrifugal pumps, ball or roller bearings may be used instead of sleeve bearings, and frequently you'll find a Kingsbury thrust bearing to identify the part used on large centrifugal pumps. At each end, where the pump shaft passes through the pump casing, we find packing glands being used to minimize leakage. This particular pump uses replaceable packing, while other pumps may use mechanical seals. As you can see, the major parts of a centrifugal pump are associated with a rotating element. So let's take a closer look at the rotating element by itself and identify the parts on it. The heart of the rotating element is the pump shaft. Depending on the design of the pump and its driver, the shaft may be an extension of the driver's shaft, or, as in this case, it may be independent and intended to be coupled to the shaft from the driver. Mounted on the pump shaft, we find the impellers. This particular pump has two impellers. The number of impellers varies with pump design and application. In fact, I've seen pumps with as few as one and as many as 27 impellers. The impeller is a pump that applies energy to the fluid as it passes through the pump. The opening in the center of each impeller is called the eye. This is where the liquid flows into the impeller. Vanes or blades in the impeller direct the flow of fluid, while the impeller shrouds, which enclose the blades, contain the fluid in the impeller area. Some, but not all, centrifugal pumps make use of packing sleeves. These sleeves fit over the shaft and, as their name implies, provide a surface for the packing to ride on. This way, any wear caused by the packing is taken by the sleeves and not by the shaft itself. In this particular design, the sleeves thread onto the shaft and hold the impellers in place. As you can imagine, it's important that we have a minimal clearance between the impellers and the casing. Excessive leakage between the two will reduce the efficiency of the pump. This is an area where wear is likely to occur, and replacement of the parts involved can be, well, I think, expensive. For this reason, many pumps make use of wearing rings. These concentric rings, one mounted on the rotating impeller and the other held stationary in the casing, will take any wear that occurs, and they can be replaced more readily and at less cost than could the impellers or the casing. Well, I think with that we've covered the major parts, you might say, of a typical centrifugal pump. Obviously, the pumps that you're going to be working on may or may not resemble the example that I showed you. But in any case, centrifugal pumps will contain most or all of the major elements that we just reviewed. I think what I'd like you to do is to stop the tape at this point. I want you to review the major components that it takes to make up a centrifugal pump with your instructor. And then when you come back, we'll begin discussing maintenance procedures for these pumps. In virtually any industrial facility, you'll find a wide variety of centrifugal pumps. For example, some pumps are extremely large, while other versions of centrifugal pumps are quite small. Pumps used to develop relatively low pressures may have only one or two stages, while pumps used in comparatively high pressure systems will have many stages. The purpose of this program is to discuss repair procedures for centrifugal pumps. And what we've done for this program is to select what we feel is a typical example of a commonly occurring centrifugal pump. The
particular model that we're going to be looking at is a horizontally split case pump, and it has 2 stages. And what we're going to be doing in this program, as I said, is discussing repair procedures. So we're going to follow an overhaul of this pump from start to finish and take a look at each key point along the way. So I suppose the first thing we ought to discuss is, why do we overhaul centrifugal pumps? Well, basically, we overhaul these pumps for one of 3 reasons. These 3 reasons are a periodic maintenance program, a loss of efficiency, or a failure. Now, what do I mean by those? Well, in some facilities, a periodic or routine maintenance program is used, which means that any given pump is overhauled on a periodic basis. In other facilities, the pumps are overhauled because of a loss of efficiency. What this means is that periodic observation of pressure and flow rates indicates that the pump is not performing as well as it once did. So at that point, it's torn down for overhaul. And failure, of course, is fairly obvious. What this means is the pump or a portion of the pump has failed. So those are the 3 reasons, then, that a pump overhaul may be required. In the case of our pump, we're going to be overhauling it because we observed a loss of efficiency while in operation. And as good maintenance practice requires, we will thoroughly review the information found in the manufacturer's instruction book before beginning the overhaul procedures. I should alert you there's a couple of procedures that we have already taken care of. One very important one is we've complied with the tagging procedures in our facility. That is, we verified that the pump is isolated, both mechanically and electrically, and that the necessary tags are hung at all points of isolation for our protection. Now, another thing we've done, because couplings are covered in another module of this training program, we have already disconnected the coupling between the pump and the drive motor. So we're ready to begin the first step of disassembly of the pump. And that first step is a cleaning operation. Now, the amount of cleaning required in any given case is going to be determined by the pump and by the environment in which it's been operating. The important thing to remember is to clean it sufficiently that you have removed all foreign material from any mating surface areas. Now, in this case, the casing of the pump is split horizontally, so it is important that it be carefully cleaned along the mating flanges, because dismantling of the pump would involve lifting the upper half of the case, and any foreign material left in the flange area could possibly get inside the pump once it had been opened up. Now, the next step, then, in preparing to dismantle the pump, once this necessary cleaning had been completed, was to unbolt the 2 packing gland followers. Now, this particular pump used conventional packing to seal around the shaft at each place where the shaft came out of the pump casing. So what was required was to loosen and remove the nuts which held the gland followers in place, and then pull the gland followers back on the shaft. Now, in some pumps, you'll find the gland followers are constructed in 2 pieces. This allows complete removal of the follower while the shaft is still in place. However, this pump was provided with 1-piece gland followers, which after they were unbolted were drawn back on the shaft, but would remain on the shaft until the rotating element was removed from the pump. So after doing this with the gland follower on the outboard end of the pump, this workman then went to the other packing gland area on the inboard side of the pump, and again removed the 2 nuts which hold the gland follower in place and drew the follower back on the shaft. Now, the packing and the lantern rings would remain on the shaft until the rotating element was removed from the pump later in the disassembly procedure. Now, the next thing that needed to be accomplished was to disconnect and remove some piping which was connected to the top half of the casing. Now, you recall I said this type of pump was dismantled by actually lifting and removing the top half of the casing. So any piping which is connected to the top half must be disconnected and removed. Now, the exact piping provided, again, will vary from one pump to another. Some pumps will have none at all. Other pumps may have several connections, such as vent connections, seal water supplies, and so forth. But in any case, any piping, instrumentation tubing, and so forth, which connects to the top half of the pump casing must be disconnected and removed to allow removal of the top casing half. Now, it's good maintenance practice, after disconnecting each piping connection, to immediately cover the opening with tape or some similar material, again to prevent foreign material from getting into the pump during later maintenance work. So once all the mating surfaces had been cleaned, after the two gland followers had been unbolted and pulled back on the shaft, and after all piping and tubing had been disconnected from the top half of the pump casing, the next job that was required was to unbolt the two casing halves. That is, to remove the nuts and bolts which attach the two halves together in preparation for lifting the top half of the casing. Now, depending on the pump design, these may be bolts and nuts, or they may be studs, which are threaded into the lower casing half with nuts on top. In the case of our pump, it was actually a combination of the two. In any event, it's important, when unbolting the two casing halves, to be sure that the loosening and removal of the nuts, bolts, or studs is done in a crisscross fashion to avoid distortion of the top half of the pump casing as the stress of the bolts is removed from it. So you'll notice in this case the workman loosened and removed two nuts on one end, then proceeded to the opposite end of the pump casing to remove their companions. He continued to work in this crisscross fashion until the entire top half of the pump casing had been unbolted. So once the unbolting steps that we've just seen are completed, we're then ready to rig up and lift the top half of the pump casing. So while our workman finishes unbolting those two casing halves, I think what I'd like you to do is to stop the tape at this point, take a short break, and review the steps we've been discussing with your instructor. Well, when we left our workman at the end of the last segment, he was unbolting the two casing halves of our pump in preparation for lifting the top half of the casing. He's now completed that unbolting step, and he's getting ready to lift that top casing half. So let's go back out in the plant and see how he's doing. Once the top half of the casing had been completely unbolted, the next step then was to connect lifting devices to it in order to lift it off the pump. Now, it's important, of course, that only approved lifting devices be used and that approved rigging practices be followed. In this case, what was necessary was not only to lift the casing from the pump, but also to swing it horizontally so that it could be set down on the floor. So two chain falls were connected to the casing, one for a direct vertical lift and the other to pull sideways. Now, the method used to initially break the seal between the two casing halves will vary from one pump to another. In most large pumps, jacking bolts will be provided in the pump flange, which can be used to break the seal. In the case of this pump, no jacking bolts were provided. So instead, the workman just took a strain on the vertical lift chain fall and then worked with the casing, rocking it back and forth in order to break the seal. Now, it's important to remember that should prying be required in order to break this seal, you should never pry on the sealing surfaces themselves, because nicks or gouges can result, and when the pump is reassembled, you're going to have a leak. Now, it's important that during the initial by its manufacturing stages that it be done vertically to avoid damage to the rotating elements inside the pump. And also, as you progressively lift the upper half of the casing, you should check inside by looking in between the two flanges in order to verify that the unit is coming apart properly. And of course, information in this regard can be gotten from the maintenance manual provided with the pump by its manufacturer. And once the top casing half was lifted high enough to clear the rotating element, and after he had verified this by a visual inspection, the workman was then prepared to start swinging the casing half horizontally. So he got a helper to man the second chain fall, while he manned the first, or vertical, chain fall, pulling the casing directly upward and verifying that it was lifted high enough to clear the rotating element. The helper took a strain on the second chain fall, which was giving us a horizontal pull in order to swing the casing sideways so that it could be moved away from the lower half of the pump casing and set on the floor. These operations continued then until the top half of the pump casing had been swung away from the pump and over the floor alongside the pump. Then the top casing half was lowered down. Now, you'll notice it was not set on the floor. Instead, the workman set it on wooden blocks. This was to prevent any possibility of damage occurring to the sealing surfaces of the casing by setting it on the concrete floor. Now, you'll also notice that in order to get it in this position required a total of 3 lifting devices. The 2 chain falls we've already seen, And in addition, a come-along was used to provide another horizontal pull. Now, it's important to remember that even on a relatively small pump, this casing half can be very heavy, several hundred pounds. And of course, on large pumps, they can reach thousands of pounds. So it's important that proper rigging practices and proper lifting equipment be used for these lifts. So what we've seen so far then is that our workman carefully lifted the top half of the pump casing. We said during the early stages of this lift, he lifted it vertically to be sure that it didn't interfere with the internal parts of the pump, causing damage. When he broke the seal between the two case halves, he did that carefully, again to avoid damage. In the case of our pump, no jacking bolts were provided, so he had to rock the casing as he lifted in order to break that seal loose. Then once he had the casing lifted clear of the rotating element, it was then swung sideways to allow setting it down on the floor alongside the pump. We said when he set it down, he did not set it on the floor. He set it on wooden blocks, again to avoid possible damage to the sealing surfaces on the casing flange. But there's one more lifting operation before we leave the casing. As we're going to see later in this program, a thorough internal inspection must be made of both halves of the casing once the pump is completely disassembled. Well, to allow inspecting the internals of the top half of the casing, it's going to have to be turned over. Okay, well, let's rejoin our workman and see how he accomplished that. Now, there are a number of ways that this can be accomplished. The exact methods used will be determined by the size and weight of the pump casing and the area in which you're doing the work. The important things to remember, again, are to use only approved lifting devices and approved rigging procedures. Now, the way the job was accomplished in this case is the workman took a shackle and installed it in one of the holes on the flange of the pump casing. He then used that shackle to attach the hooks from his lifting devices and lifted the casing into the vertical position that you see here. He placed the lip of the flange on the bottom side in the drainage trough of the pump base plate to assist him in steadying the casing while he set blocks in position on the floor. Now, the blocking is doubly important in this case. The blocks have to be sized and positioned such that they provide adequate support under the irregular shape of the top half of the casing. But at the same time, in addition to providing proper support for the casing, it also has to support it in a secure fashion. That is, we don't want this casing half falling off the blocks after it's been set in position. This could, of course, result in damage to the casing and possibly personal injury. So to recap then, the steps involved were to lift the casing, hold it in a vertical position while blocks were set in place, and then to slowly lower the casing, now in the upside down position, if you will, onto the blocks, ensuring that the blocks were positioned in such a way that they would support the casing without damage and provide assurance that the casing would remain in position once it had been lowered onto the blocks. Well, with that then, we've pretty well completed the disassembly of the casing. We've had the top half of the casing off the pump, and we have it turned over, sitting on protective blocks, ready to be inspected. The next step then in pump disassembly is to start getting ready to remove the rotating element from the pump. But I think before we get into that, what I'd like you to do is to stop the tape at this point and review what we've been discussing on casing disassembly. Well, at the end of the last segment, we had completed the steps involved in casing disassembly. We said the next major step involved was removing the rotating element from the lower half of the casing. Well, the first step in removing the rotor is to unbolt and remove the bearing covers. Now, this is an example of a time when reference should be made to all of the manufacturer's instruction book before proceeding. This is to find out the type of bearings installed in the particular pump that you're disassembling, and also to determine if any special procedures or precautions should be followed in the course of disassembling the bearings. For example, this particular pump has a water-cooled thrust bearing, and its water jacket must be removed before the rotor can be lifted. So all of the nuts which held the water jacket in place were removed to allow the removal of the water jacket itself from the pump. Now you'll notice an interesting procedure here, and one which should always be followed. You should never strike any piece of machinery with a hard metal hammer. Instead, if it's necessary to use a hammer to break something loose, such as was done here with the water jacket, you should use a block of wood or some similar resilient material between the piece of machinery you're striking and the hammer. So the workman, after removing the nuts which attached the water jacket in place, then drew the water jacket off of the end of the pump, using a block of wood and a hammer in order to break it loose and assist its transport off of the pump. Now the piping connections to the water jacket, of course, were disconnected earlier in the disassembly procedure, at the same time as he disconnected the other piping connections which attach to the top half of the pump casing. So with the water jacket drawn off the pump and set in a safe location where it would not be damaged and not be in the way of further disassembly procedures, the workman was then ready to begin disassembly of the outboard sleeve bearing. This particular pump was equipped with a thrust bearing on the outboard end and two sleeve bearings, one on the outboard end and one on the inboard end. Each of the sleeve bearings had two alignment pins installed in the bearing cover, which went into holes, which matched the pins, of course, in the lower half or bearing housing. These pins had to be retracted before the bearing covers were removed. So what we see the workman doing here is retracting these two pins in the cover on the outboard sleeve bearing. Now this again illustrates the importance of checking the manufacturer's instruction book, because the book told the workman that the two pins existed in each bearing and instructed him that they had to be retracted before the bearing covers were lifted. Now the next step involved, after retracting the two pins, was to loosen the four nuts which attached the top half of the bearing housing, or bearing cover. As with any group of nuts, bolts, or studs, it's important that these nuts be loosened in a crisscross fashion to avoid distortion of the bearing cover. And cleanliness is also important. As can be seen in this picture, the mating flanges or mating joints had been previously cleaned to avoid as much as possible any foreign material getting into the bearing when the cover was lifted. So all four of the nuts holding the bearing cover in place were loosened in a crisscross pattern. Now a gasket is used at the point where the water jacket attaches to the pump to avoid leakage at this point. As you see here, the workman removed this gasket before lifting the bearing cover so that the gasket would not be torn when the bearing cover was taken off. Now, of course, the gasket would not be reused, and you should never reuse a gasket. But where possible, it's advantageous to remove the gasket in one piece, as was done here, because this can be used as a guideline or pattern for making a new gasket later on, and makes the job of making a gasket much easier. So after the gasket had been taken off and set aside to be used as a pattern, the workman then removed the four nuts which were used to attach the bearing cover. And once these nuts were removed, of course, then the bearing cover itself could be lifted off. Now, due to the size of the pump, this particular bearing cover could be lifted off by hand. However, with larger equipment, you may find that a lifting device, such as a come-along or chain fall, is necessary in order to safely lift a bearing cover. But as I said, in this case, once the nuts were removed, this cover could be lifted by hand. And as before, a block of wood and a metal hammer were used in order to break the seal between the bearing cover and the lower half of the bearing housing. So by holding the block of wood at the joining surface and striking it with a hammer, the seal between the two halves of the bearing housing could be broken. Once this had been accomplished, then, the workman was free to grab the bearing cover by hand and lift it off. Now, a certain amount of care is necessary here. You don't want to damage the threads on the studs, nor do you want to damage the bearing surfaces. So the cover should be carefully lifted, and if it binds, further assistance should be given. As when lifting the top half of the pump case, it's important that you not pry on the sealing surfaces, because damage to the surfaces can result. Instead, it's a much better procedure to use a block of wood or some resilient material and a hammer in order to assist the movement of the bearing cover. Once the cover is broken loose, then it was grasped by hand and lifted off of the pump. Now, the bearing cover, of course, was again set aside in an area where it would not be damaged and where it could be inspected carefully later on. So with that then, our workman has completed all of the bearing disassembly steps which are necessary on the outboard end of the pump before the rotor can be lifted. The next thing he had to do was proceed to the inboard end of the pump and, following the same steps we've just seen, remove the cover from the sleeve bearing at that end of the pump. After this has been done, of course, he's completed all of the steps necessary before physically lifting the rotor out of the lower half of the pump casing. On some pumps, however, there's a number of checks and measurements that should be performed before the rotor is lifted out. If this is a requirement on a particular pump you're working on, it will usually be specified again in the manufacturer's instruction book. I might give you a couple of examples of the type of measurements that you may want to do at this point. One example would be to check wearing ring clearance by inserting feeler gauges between the stationary and rotating wearing rings. Another check frequently performed at this point is a run-out check on the shaft. This is done using a dial indicator and, of course, turning the shaft by hand. Another check that may be appropriate at this point is to measure the height of the shaft at each bearing, again using a dial indicator. This is an indication of bearing and lift the rotor condition alignment. Now, if any of these measurements are required at this point, you should, of course, carefully note the results of the measurements. So these values can be compared against specifications to determine if particular types of repairs are called for. Well, I think with that, we have covered all of the steps which may be involved in preparing to lift the rotor out of a pump casing. And the next step, of course, is to rig up and lift the rotor. But I think before we get into that, what I'd like you to do is to stop the tape at this point and review what we've been discussing with your instructor. Well, if you'll recall, at the end of the last segment, we said we had now completed all preparatory steps before actually lifting the rotor out of the pump casing. So I suppose that's the next thing that we should be discussing. So again, let's go back out to the plant and see how this step is accomplished. A great deal of care must be taken when lifting the rotating element out of a pump such as this one. If you're not careful, you can cause additional damage to components in the course of the lift. And as before, only approved lifting devices and approved rigging procedures should be used. So in this case, a sling was attached to the rotor at each end, and a chain fall was used in order to lift the rotating element from the lower half of the pump casing. Now, it's extremely important that during the initial stages of this lift, it be strictly vertical to avoid damage to the components of the pump. Now, you'll frequently find, as the workman found in this case, that the rotor is bound up or hung up in the casing. This is because of the friction of the packing, and also because you're lifting the stationary wearing rings with the rotor. So this may require a certain amount of rocking or possibly prying in order to break the rotor loose from the casing. If prying is required, as it was in this case, as before, use care to avoid prying on any sealing surface or any important surface of the rotor, such as the bearing surface area. Pump lantern rings are frequently made in 2 or 3 pieces, as opposed to a 1-piece ring. For example, in this case, the lantern ring was a 2-piece ring. So as the shaft cleared the lower half of the pump casing, the lantern rings fell away, and the workman removed them. From this end, he also removed 1 ring of packing, which fell away as the rotor was lifted. He then went to the opposite end to see how the lift was proceeding, and again removed the 2-piece lantern ring as it fell away from the shaft. As I said earlier, it's important that this portion of the lift be strictly vertical to avoid the shaft swinging and causing damage to the stationary or rotating components. However, once the shaft has been lifted somewhat, it's usually going to be necessary, as it was in this case, to move it horizontally in order to swing it away from the pump casing and allow putting it down in a convenient location. So after performing the initial and most critical portion of the lift, the workman then connected a second chain fall to the sling that was attached to the rotor, so that as the lift progressed, he could control both the vertical and horizontal movement of the shaft. So they continued the lift, using care to verify that damage was not occurring and controlling the swing of the rotating element. They continued to lift vertically until the rotating element was high enough to clear the lower half of the casing. As will frequently happen, the lower shell of the inboard sleeve bearing came up with the shaft, so the workman removed it from the shaft and set it in a safe location so that it could be. As I said, the workman continued to lift the shaft in this manner, being careful to avoid contact between the rotating element and any portion of the lower half of the casing to avoid damage. And then once the rotating element had been lifted high enough to clear the lower half of the casing, they then coordinated the operation of the two chain falls to begin a horizontal movement of the rotating element so that it could be set in a safe location. Now we have the same concerns when setting a rotating element in place as we had when we set down the top half of the casing. It must be placed in such a manner that it does not present a hazard to personnel and that it is not damaged. This can be done in several ways. In some locations, you'll make use of wooden blocks with V-notches cut in them so that the rotor is held in position. In this case, a fabricated cart was used. The cart was made of steel and again had several V-shaped supports in which set. Now the supports were carefully positioned such that damage to the rotor would not result. That is, the supports were under areas of the rotor that are not normally load-carrying areas. By that I mean there was not a support under a bearing surface, for example. Now the next step required here was a transportation step. Once the rotor had been safely placed in the cart, the lifting devices were disconnected from it, and it was transported to a shop area for later disassembly. As we're going to see later on, this later disassembly includes some precision measuring, and that's why it was deemed more appropriate to do it in a shop environment rather than do it at the location of the pump. So let's briefly review then what we've done to our pump so far in the course of disassembly. We've cleaned it to prevent foreign material getting into it, or to minimize the amount of foreign material that got into it. We have disconnected any piping that was necessary in order to gain access to the various parts that we needed to remove. We unbolted and removed the top half of the pump casing, and we said we set it aside upside down so that we were ready to inspect it. We then directed our attention to removal of the rotating element. In order to accomplish that, we had to partially dismantle the bearings. We had to remove a water jacket, in the case of this particular pump, from the thrust bearing, and we had to remove the two bearing covers, one on each of the two sleeve bearings. Next then, we could physically remove the rotor itself by lifting it out of the lower half of the pump casing. And we said that in some cases there may be some measuring steps necessary before the rotor is actually removed. We still have a few more steps we need to discuss then before the pump can truly be said to be fully disassembled. We now have both halves of the casing available for inspection, and of course we still have to finish the disassembly of the rotating element. But I think again this might be a good point to take a break. So why don't you stop the tape at this point and review the material we completed in discussing. Well, when we left our workman at the end of the last segment, he had just removed the rotating element from the pump that he was disassembling and was in the process of transporting it to a shop before he completed the disassembly of the rotating element. However, before he did that disassembly step, he still had one further job to do at the pump site, and that was a thorough and complete inspection of the pump casing. And I mean both halves of the pump casing, both the lower half, which of course is still in place, and the upper half, which he'd removed earlier, set aside upside down, prepared for inspection. So let's catch up with him out at the pump and see how he performs this inspection. Most facilities will make use of a checklist of some type to allow recording the results of this inspection. And of course, in addition to the checklist, it's important that reference be made to the manufacturer's instruction manual, which was provided with the pump, because this manual will provide valuable information regarding which items should be inspected and what particular items should be looked for. That is, specific areas of the pump where certain types of damage or wear may have occurred. And we're going to go through here and see a typical inspection, and I'll try and point out the key points and important items that should be checked in the course of performing this inspection. A certain amount of cleaning is required in order to allow an adequate visual inspection. For example, what we see here is cleaning of the studs, which are used to hold down the bearing caps, and if you recall, a certain number of studs were used on this pump in order to attach the two casing halves together. It's important whenever examining threads that they first be cleaned with a wire brush or some similar tool so that you can visually examine the threads and determine their condition. If they're left dirty, obviously you could miss a broken or damaged thread. So the workman here is cleaning the threads to allow a visual inspection of them to determine if any of the studs are in need of repair or replacement. He also cleans the studs that were associated with that water jacket that we saw earlier on the thrust bearing, so that those threads too can be examined. And in addition, the studs that you see him cleaning now are ones that are used to hold the two casing halves together. You recall the casing was assembled using a combination of studs and bolts and nuts. Another area which requires careful examination on a pump such as this is the stuffing box, because this is an area where erosion damage frequently occurs. A small amount of leakage over a long period of time can result in erosion of the stuffing box. If this is not identified at this point and corrected before reassembly of the pump, then even though the pump has been rebuilt and overhauled and new packing and so forth has been installed, you're still going to have excessive leak-off. So it's important that the stuffing box areas be carefully cleaned and examined. And as I said earlier, the results of all these inspections should be noted, and most facilities make use of a checklist for this purpose, just to be certain that no items are missed. So these steps are essentially repeated throughout the examination of the pump. Various areas are cleaned, and after cleaning, a visual inspection is performed in order to determine if repair work or replacement of components is required. Now this extends right into the casing itself. A careful cleaning should be accomplished inside the casing, with particular emphasis on the grooves in which the stationary wearing rings fit. These grooves should be carefully cleaned out, as we see the workman doing now, and then visually examined for any evidence of wear or leakage which has been occurring around the wearing rings. Again, if evidence of wear is evident, then we're going to have to take corrective action in order to repair it before the pump is reassembled. You should also just generally examine all areas inside the casing, with particular emphasis on the pump volutes. What you're looking for here is possible erosion damage which has occurred because of flow of water through the pump over a long period of time. And again, if excessive wear is evident in any area, then repair work should be initiated at this point so that the repairs can be accomplished before the pump is assembled. Now the technique you see here is frequently used to clean out wearing ring grooves. The workman used his wire brush to break loose the material which had accumulated in the grooves, and then used a rag over the end of the brush in order to remove this foreign material to allow a careful examination. Then he could get right in there and visually examine the grooves to determine their condition. And as before, the results of his examination will be noted on the sheet provided for that purpose. I can't overemphasize the importance of recording the inspection results. These records are used to plan future maintenance, as well as to ensure that all necessary repair work is accomplished before reassembly of the pump. Now these same basic steps of cleaning followed by inspection are repeated until the entire pump casing has been examined. And what we see here, the workman is working on the studs which assemble the other sleeve bearing. And you'll notice that he uses a rag to cover the bearing shell while he's wire brushing the studs. This is to minimize any foreign material getting on that bearing surface. After cleaning the studs, the condition of their threads is determined, and as before, will be noted on the sheet. Now, the same inspection procedures that we've just seen on the lower half of the pump casing, of course, are repeated for the upper half of the pump casing. As before, stuffing box areas, wearing ring grooves, and so forth need to be cleaned and carefully inspected. In addition, the entire parting flange area on both casings needs to be cleaned and examined for evidence of leakage or erosion. And as with the others, the results of this inspection are carefully logged. In addition, each bearing shell should be removed from its mount, either in the pump case, as we see here, or from the bearing covers with regard to the upper bearing shells. And when it's removed, it should be carefully cleaned. And I do mean carefully, because if you use an abrasive material or a wire brush or something like this, you can cause damage to the bearing material. Instead, it should be wiped clean with a clean rag and then visually inspected. Now, later on in the program, we're going to discuss some precision measuring of these bearing shells for a more precise determination of their condition. But for the time being, we're talking about a visual examination. So what we're looking for is gross wear. Either the bearing is good or it is bad for our purposes at this time. So each of the shells should be removed, cleaned, visually inspected, and then for the time being set back in place to prevent possible damage. So there's a number of steps involved then in performing a proper casing inspection on a centrifugal pump after it's been opened up. So before we close this segment on casing inspection, I think it might be wise to review the key points that you should be checking on a casing inspection. You should check the threads on studs or bolts which are used to assemble the pump. You should check the condition of the parting flange, looking for evidence of leakage or erosion. You should check the condition of the wearing ring grooves in the casing, and this is on both halves of the casing, of course. You should also just check the casing in general, looking for erosion and other forms of wear or damage. You should be sure and check the stuffing boxes. You recall we said this was an area where substantial erosion can occur. And of course you should check the condition of the bearings. And if sleeve bearings are used, as they were in our pump, they should be carefully examined. And finally, you should simply check the condition of all bolts which are used to assemble the pump, as well as dowel pins and other miscellaneous parts to determine if replacement is required. Well, we've covered quite a bit of material on casing inspection. The next thing I'd like to do is to catch up with our workman out in the shop, see how he goes about disassembly of the rotating element. But I think before we get into that, what I'd like you to do is to stop at this point and review casing inspection procedures with your instructor. What I'd like to do in this segment is to discuss with you the steps involved in disassembling the rotating element of a centrifugal pump. Now, the last place we saw the rotor out of the pump that we've been disassembling, it was being transported to a shop. And we said in that shop the workman was going to continue the disassembly of the rotor. So let's go out to the shop and see how he's doing. After checking the manufacturer's instruction manual, the workman began disassembling the rotating element of the pump from the outboard or thrust bearing end. And the first items he removed were the two bearing slinger rings. These rings provide oil circulation for both the outboard sleeve bearing and the thrust bearing. The next thing he did, using a wrench of the proper size and a striking hammer, was to loosen and remove the nut on the end of the shaft, which holds the thrust bearing sleeve in place. Now you notice as he strikes the wrench that the two shells for the thrust bearing came apart. The only thing that had been holding these together was the friction of their alignment pins. After he had loosened the nut with a wrench, he then removed the nut and washer from the end of the shaft, using care to hang on to the thrust-bearing shells so that they did not fall and become damaged. After he'd removed the nut and washer, he then removed the two halves of the thrust-bearing shells. Now these shells need to be examined in much the same manner as we've already seen as applied to the shells for the sleeve bearings. They need to be wiped clean of oil and visually inspected. Now later on in the program we're going to see a precision measurement involving these shells to verify that they are in fact good for reuse. However, at the point of disassembly, what's required is a visual examination, simply to determine whether they are grossly damaged or not. So what the workman did with each shell was to wipe it clean using a clean rag to avoid damage to the bearing surfaces for the other from his cleaning operations, and then visually examined it, looking for signs of excessive wear. Now, this particular type of thrust bearing has several collars on the shaft which ride in the grooves that you see here on the bearing shells, and the babbitt or bearing surfaces are in the grooves. So this is primarily what was being examined by the workman. He then repeated the operation for the other shell, wiping it clean with a clean cloth so that dirt and oil was removed to allow a thorough visual examination. After these two components had been removed from the shaft and visually examined, he then set them aside on the table where they would be protected and available for later inspection and measurement. He then was ready to return to the rotating element and continue the removal of parts. Now, the next part that he removed was the bearing seal. This grooved disc turns on the shaft and has a mating lip in the bearing housing, and its purpose is to limit the amount of oil which leaks out of the bearing along the shaft. So after removing it, he wiped it clean and again visually examined it for signs of excessive wear. He then wiped off the journal for the outboard sleeve bearing and also the thrust bearing collar. On this particular pump, the thrust bearing surface is not a part of the shaft itself, but is a sleeve or collar which fits over the end of the shaft and is held on by the nut that we already saw being removed. So he wiped down the sleeve again to allow a visual examination. He next removed the gland follower. On this particular pump, this is a one-piece follower, so the only way it can be removed is the way we see here, slid off the end of the shaft. Once it's been removed, it too was examined for signs of excessive wear. Now, with the gland follower removed, he could then remove the packing which was remaining on the shaft. Now, you recall that some of the packing and the lantern rings were removed as the rotating element was removed from the casing. The packing, of course, would be discarded and new packing used when the pump was reassembled. The next item to be removed was the bearing sleeve. The workman used a hammer and a block of wood to prevent damage while he tapped on the sleeve in order to break it loose. Then it was slid off of the end of the shaft. Then, as with the other parts, the workman inspected it before placing it on the table. The next item he needed to remove was another sleeve. However, before he could accomplish this, he had to reposition the rotating element in its cradle. So using a lifting device, he lifted it free in order to block it up, to expose this end of the shaft to allow the remaining components to be slid off. Now, it's important when this type of work is necessary to carefully block up the shaft. That is, to be careful where you place your blocks such that the weight of the shaft is not going to cause damage. For example, you would not want to place a block directly under an impeller because the weight of the rotating element on the impeller could damage it. Instead, the block should be placed under an area of the shaft which is not a machined surface and is not a component which needs to be removed from the shaft. And of course, it should be blocked up in such a way that it's not going to get away from you, damaging the parts or possibly causing personal injury. So in this case, the rotating element was lifted in the cradle and wooden blocks were placed under the shaft in such a way that when it was lowered down, it would rest at an angle to allow the remaining parts to be slid off this end of the shaft. And it was still cradled in the V-shaped supports on the back of the cart, which would prevent its rolling off, causing damage or possible personal injury. After it was established in the proper position, then the lifting device could be lowered down to allow the sling to be removed from the shaft so that the remaining parts could be taken off. So the workman checked and verified that it was secure and then removed the sling. Now, the next component to be removed, as I said, was another sleeve. And this sleeve serves several purposes. It holds the impeller in place on this end of the shaft, and it also provides a surface for the packing to ride on. In this pump design, the packing, like the thrust bearing, does not ride directly on the shaft. Instead, it rides on a replaceable sleeve over the shaft. In this particular pump, the packing sleeves are threaded onto the shaft. So the workman made use of a spanner wrench and a hammer to break it loose, and then unthreaded the sleeve from the shaft and removed it. Once these sleeves are removed, they should be carefully examined for evidence of wear. It may be possible to repair them by machining, or if the wear is heavy, they should be replaced before the pump is reassembled. Now, the next item that the workman removed was an item called a wearing ring. Once the ring was removed, it too was placed on the table, ready for later inspection and measurement. The next item removed was the impeller itself. With its retaining sleeve off, the impeller could be slid off the end of the shaft. However, due to its size and weight, 2 men were required in order to safely remove the impeller. So the 2 of them, working together, slid the impeller off of the shaft and placed it on the table, again ready for later inspection and measurement. Now when the impeller was drawn off, you'll notice that another stationary wearing ring fell loose. That ring too was removed and placed on the table so it could later be inspected and measured. The next item to be removed was a channel ring. Although this part appears to be mounted on the shaft, it really isn't. The shaft is free to turn in the channel ring. When the pump is assembled, the channel ring is held in place in the casing, much like a stationary wearing ring. The discharge from the first stage impeller passes through the channel ring before going into the eye of the second stage impeller. So the channel ring was removed from the shaft and placed on the table with the other parts. Now, of course, this does not complete the disassembly of the rotor, but we've seen all of the major steps involved. What was required from here was simply to turn the rotor around, remove the remaining components from the opposite end in the same fashion as we've just seen. Now, once all of these components have been removed and laid out on a table or some similar area, the next important step that needs to be done is to carefully examine and measure a number of these components. And here we're dealing with some precision measurement in order to determine where repair work is necessary or which components need to be replaced. And that's the next thing I'd like to discuss with you, this inspection and measuring steps. You'll find this information on the next tape in this particular training module. But as usual, before starting a new subject area, what I'd like you to do is stop at this point, review what we've been discussing on rotor disassembly with your instructor.